Hi friends, in this video I am going to explain you the simple stresses and strains. So let me tell you about the stress. So first, stress. Stress is nothing but every material is elastic in nature. That is why whenever some external system of forces, so if you take a body like this, so some external force is acting upon a body, so what happens? So it undergoes some deformation. As the body undergoes deformation, its molecules set up some resistance to deformation. This resistance per unit area, so this resistance in the sense the resistance offered by the body per unit cross-sectional area is treated as stress. So it is designated as sigma, that is equal to P by A, where P is the load. P is nothing but load or force on the body. So here A is nothing but area of cross section. So the units, SI units of stress is nothing but Pascal. So Pascal, that is equal to 1 Newton per meter square. In actual practice, we use bigger units of stress, that is megapascal, that is MPa, and gigapascal, so which is equal to Newton per mm square and kilonewton per mm square. Okay, now let me discuss strain. What is strain? As already mentioned, whenever a single force or a system of force acts on the body, it undergoes some deformation, and the deformation per unit length, so the body deforms, the deformation per unit length is known as a strain. Mathematically it is given as, so strain is equal to change in length by original length. So in this place of length you can take any dimension also. We have length, breadth. Okay, so or delta L is equal to strain into length. Write small a or like this. Okay, no problem. So delta L is nothing but change of length. L is equal to original length. Okay, so these are the basic things, stress and strain. So there are different types of stresses, that is tensile stress, compressive stress, and also the shear stress. The strains also we have different things. Now let me discuss about the Hooke's law. So Hooke's law is very important in the subject point of view and examination point of view for the diploma examinations. Hooke's law, it can be asked in the short answers, that is about 3 marks questions. So it states that when a material is loaded, within the elastic limit, stress is directly proportional to strain. That means nothing but stress sigma is directly proportional to strain. Okay. So here comes the thing, modulus of elasticity. When you remove this proportionality thing, so you will get a constant like E into strain. That E is nothing but stress by strain is nothing but Young's modulus. Okay. Young's modulus, or the constant of proportionality known as modulus of elasticity or Young's modulus. So the units are same as stress, because we don't have the units for the strain. We don't have any units for the strain. So the value of the modulus of elasticity, modulus of elasticity E, that is modulus of elasticity E can be, so for steel we can discuss like steel we have 200 gigapascal. For wrought iron that is about 190 gigapascal, and for also timber we consider we have 10 gigapascal, like this. So different materials have different modulus of elasticity at different constant values. So let us discuss some basic problems in this chapter. So let me discuss with the first question. So this is the first question I'm going to discuss. So I'm picking up with the basic things. So first question is like this. You can observe. In an experiment, a steel specimen of 13 mm diameter was found to elongate 0.2 mm in a 200 mm gauge length. When it was subjected to a tensile force of 26.8 kilonewtons, if the specimen was tested within the elastic range, what is the value of Young's modulus for steel specimen, he is asking. So first take the given data in the question. Given data. So in the experiment, a steel specimen of 13 mm diameter. So given diameter is equal to 13 mm. Okay, note it down. And elongate in the sense delta L is equal to 0.2 mm. So actual length L is equal to 200 mm. Okay, it was subjected to a tensile force. So force is given as force is nothing but P is equal to, what is the force? 26.8 kilonewtons. If the specimen was tested within the elastic limit is said. So we can find the area of cross section A is equal to pi by 4 into d square, that is equal to pi by 4 into what is d? D is given as 13 mm 13 square. So you will get the value like 32.73 mm square. So for the elongation, delta L you want, right? Delta L. So what is he is asking about? E, Young's modulus. So what is the value we have? Delta L. For delta L we have PL by A into E. So actually E is equal to stress by strain, that is equal to P by A divided by delta L by L, that is equal to PL by A into delta L, right? So in this format also you can do like this. So E is equal to PL by A into delta L. So all the values we have. So that is P 26.8 into L is 200 divided by A 132.73 we have, and into delta L. What is delta L? Delta L is 0.2. You can substitute in the values, and you can get from the cals. The value is about 40.38 by 0.2, that is equal to 201.9 kilo Newton per mm square. So this is our final answer, right? So thank you for watching. Thank you so much.